Hello everyone. Today I'm here with you all with one of the topic of class 8th maths curriculum, that is special types of quadrilaterals. In this video, we will be learning what quadrilaterals is, what all are the types of quadrilaterals like your trapezium, parallelogram, kite, their properties we will be learning, and some important questions related to it we'll be learning in this video. So let's start with the topic. So first of all, what quadrilateral is? In our previous videos, we have seen that what polygon is. Polygon is a closed figure which is only made up of line segments. So whenever we are talking about polygon, that simply means a closed figure which is only made up of line segment is known as your polygon. And when we are saying that the polygon is having four sides, then such type of polygons are known as your quadrilaterals. That means quadrilaterals are the polygon with four sides. Any of the polygon which is having four sides is known as your quadrilateral. So over here we can see that this is a quadrilateral because it is having four sides. Suppose it is your A, B, C and D. So we can see over here that the quadrilateral ABCD is having four sides. They are having four sides. One is your AB, BC, CD and AD. So quadrilateral is having four sides, four angles it is having, four vertices it is having, and your two diagonals it is having. So a quadrilateral which we are talking about is your ABCD. It is having your four sides, and the sides are your AB is one of the side, BC is one of the side, CD and your DA. These are the four sides of your quadrilateral ABCD. Now the four vertices it is having your four vertices, that is your A, B, C and D. These are the four vertices of the quadrilateral ABCD. There are four angles are there. Which four angles are there? This is one of the angle. All these are the angles of the quadrilateral ABCD. So this angle could be written as angle DAB. This is one of the angle. Angle your ABC, angle BCD and angle CDA. These are the four angles of the quadrilateral ABCD. We can name it as angle 1, 2, 3, 4 even for convenience in writing. So quadrilateral is a closed figure. It is a polygon which is having four sides, four vertices, four angles. And we have even learned that if we are going to join any of the vertex with the non-consecutive or the non-adjacent vertex, then we are getting the diagonal. So a quadrilateral is having two diagonals even. Quadrilateral is having two diagonal. For this quadrilateral, the diagonals will be your AC and your BD are the diagonals. So a quadrilateral, that means four-sided polygon, is having your four sides, four vertices, four angles and two diagonals. We have also learned that if we are talking about any of the polygon which is having n sides, then the sum of interior angles of all the interior angles, it will be given by your 2n minus 4 into 90. It is sum of all the interior angles of a n-sided polygon. Sum of interior angles of a n-sided polygon. Over here the value of n is your 4 because it is a four-sided polygon. So value of n will be 4 over here. So we can find the sum of all the interior angles of a quadrilateral. It will be, we will replace n by your 4. So it will be 2 multiplied by 4 minus of 4 multiplied by 90. 2 multiplied by 4 will be your 8. 8 minus 4 will be your 4. 4 multiplied by 90. That means sum of all the angles of a quadrilateral will be your 360 degree. We can see over here that sum of all the interior angles of the quadrilateral, it is having four angles. So sum of all these four angles of a quadrilateral will always be your 360 degrees. So this is all about your quadrilateral, that it is a polygon with four sides, four vertices, four angles, two diagonals, and sum of all the interior angles of the quadrilateral will be your 360 degree. Now let's see some of the types of the quadrilateral. Types of quadrilateral. Whenever we will be talking about quadrilateral, that means we are talking about only a four-sided polygon only. So there are three types of quadrilaterals are there. One is your trapezium, Trapezium is one of the type of the quadrilateral. Another is your parallelogram, and third is your kite. These are the three types of your quadrilaterals. Now let's see what trapezium is. First of all, we are coming to your trapezium. So when we are taking a four-sided polygon, because whenever we are saying it is a quadrilateral, that means we are simply talking about a four-sided polygon only. Suppose its naming is your A, B, C, D. So if one pair of opposite side is parallel to each other, then we say such type of quadrilateral to be a trapezium. Over here we can see that AB is parallel to your CD. Although they are not equal, but they are parallel to each other. If any one pair of opposite side is parallel to each other, then we say such type of quadrilaterals to be trapezium. Over here we can see that AB is parallel to your CD. One pair of opposite side is parallel in the case of your trapezium. So this is the condition for any of the quadrilateral to be trapezium. If we have to prove that this given quadrilateral is a trapezium, then we need to prove is that one pair of opposite side of the given quadrilateral is parallel. If we can prove it, we can say that the given quadrilateral is a trapezium. Now, what the properties of a trapezium will be, because just now we are saying that AB is parallel to your CD. And if AB is parallel to CD, we can see AD is the transversal for this case. So, angle A and angle D. Sum of these two angles will be your 180 degree. Similarly, now AB is parallel to CD even, and here this is BC is the transversal. So, sum of angle B and angle C will be your 180 degree. If angle A is your 1, 2, I am simply naming it to write it easily. So over here we can see angle 1 plus angle 4 will be your 180 degree. Similarly, angle 2 plus angle 3 will be 180 degree. These are the properties of a trapezium, that one pair of opposite side is parallel and your adjacent angles, not adjacent angle, we can say angle 1 plus angle 4, because AB is parallel to CD and AD is the transversal and BC is also the transversal. So sum of angle A1 plus angle 4 will be 180 degree. Similarly, sum of angle 2 and angle 3 will even be your 180 degree. Now, if your non-parallel sides, which are the non-parallel sides over here, we can see AD and BC are the non-parallel sides. If non-parallel sides are equal, in that case we say such type of trapeziums as your isosceles trapezium. Such type of trapeziums are known as isosceles trapezium. When your non-parallel sides AD and BC are the non-parallel sides. So if non-parallel sides are equal, then such type of trapeziums are known as isosceles trapezium. So how the figure will look like? This is a trapezium. Suppose this is your A, this is B, this is C, and this is D. AB is parallel to your CD. And the non-parallel sides are your AD and your BC. So AD is equivalent to your BC. Whenever we are making these arrows, this shows that these lines are parallel. And when we are making like this, either one line or two lines even we can make, then this shows that AD is equivalent to your BC. This is the, we can denote it. Now, if non-parallel sides are equal, that means if AD is equivalent to your BC, then we say that such type of trapeziums are known as your isosceles trapezium. So what all are the properties of an isosceles trapezium? For the isosceles trapezium, your base angles are equal. That means angle D will be equivalent to angle C and angle A will be equivalent to your angle B. For an isosceles trapezium, angle A will be equivalent to angle B here and angle C will be equivalent to angle D. This is the property of an isosceles trapezium. Although it is not the property of your simple trapezium, but if your non-parallel sides will be parallel, that means if it is an isosceles trapezium, in that case angle A will be equivalent to angle B and angle C will be equivalent to angle D. Along with that, their diagonals will even be equal. Over here we can see there are two diagonals are there. So diagonal AC will be equivalent to your diagonal BD. these two diagonals will even be equal. Whatsoever the properties of a trapezium is there, it is going to follow that. That means one of the sides, one of the pair of opposite sides will be parallel. AB will be parallel to CD. Along with that, angle A plus angle D will even be 180 degree. Angle B plus angle C will even be 180 degree. It is a trapezium, but some special properties even it will be holding, because it is an isosceles trapezium. That's the reason angle A will be equivalent to angle B, angle C will be equivalent to angle D, and diagonal AC will be equivalent to diagonal BD. These are the properties for an isosceles trapezium. Now we will be seeing that what parallelograms is, what kite is. There are three types of parallelograms are there that we will be learning in this video only. One is your rectangle. Rectangle is a special type of parallelogram. Along with that, rhombus is even a parallelogram, and your square is even a type of parallelogram. So what parallelogram is, what all the properties of a parallelogram, what all the properties of rectangle, rhombus and squares are, what is the property of kite, that all we will be learning in this video. Now let's understand what is a parallelogram and what all are the properties of a parallelogram. So in the case of trapezium, we were saying that only one pair of opposite side is parallel. If this is the condition, then a quadrilateral is a trapezium. But in the case of parallelogram, if both the pair of opposite sides are parallel to each other, then we say that such type of quadrilaterals are your parallelogram. So if I am saying that this is a parallelogram, which is your ABCD is a parallelogram, then both the pair of opposite sides will be parallel to each other. That means AB will be parallel to your CD and AD will be parallel to your BC. If both the pair of opposite sides in a quadrilateral are parallel to each other, we say such type of quadrilaterals to be parallelogram. So over here we can see that AB is parallel to your CD and BC will be parallel to your AD. Again, what all the properties of a quadrilateral is there, it is going to follow, because it is even a quadrilateral. That means sum of all the angles, that is A, B, C, D, it will be your 360 degree. Now what else are the properties of a parallelogram? Let's understand it. So some other properties of a parallelogram is that your opposite sides of a parallelogram could be written like this even. Parallelogram are equal. That means your AB will be equivalent to your CD. These are the opposite sides. So AB will be equivalent to CD and AD will be equivalent to your BC. In a parallelogram, both the pair of opposite sides are equal. Opposite angles are equal. Opposite angles are equal. That means angle A will be equivalent to angle C and angle B will be equivalent to angle D. All these are the properties of a parallelogram. Along with that, diagonal of a parallelogram divides it into two congruent triangles. That means two similar triangles, it will be dividing the diagonal of the parallelogram, will be dividing the parallelogram into two triangles, and these two triangles will be congruent, they both will be similar, they both will be equal. So how we can prove all these theorems? We can say these are the theorems only, because these are the statements which are true for each and every condition. Whatsoever the condition will be taking of the parallelogram, for each and every condition these statements will be true, and that's the reason they are your theorems, even because it can be proved. The statements which can be proved are your theorems. So how we can prove all these statements? Let's understand it. Suppose I am saying that this is a parallelogram A, B, C, D. This is a parallelogram, and we know that in a parallelogram both the pair of opposite sides are parallel, only parallel. This is the condition for a quadrilateral to be a parallelogram. Now we have to prove all this. We cannot take all these as your assumption, we cannot take it. We have to prove all these three statements. Simply what we can take is that both the pair of opposite side is parallel. Only this we can take. So ABCD, in this AB is parallel to your, so what is given to us is AB is parallel to your CD. This is given to us. Along with that, it is even given that AD is parallel to your BC. It is given to us. We have to prove that opposite sides are equal. That means AB is equivalent to your CD. This we need to prove. AD is equivalent to BC. This we need to prove. Opposite angles are equal. That means angle A is equivalent to angle C. We need to prove. Angle B is equivalent to angle D. It is equal, that we need to prove. And diagonal is dividing into two congruent triangles. That means we need to prove that triangle ABD is congruent or say equal to your triangle CDB. All this we need to prove. So how we can prove it? We have made the diagonal BD. We have joined your BD. So construction is we have joined your BD. This is the construction. We know that this line AB is parallel to CD. So this angle ABD, this angle, suppose it is your angle 1 and this is your angle 2. Angle BDC, this is your angle 2. So angle 1 and angle 2 are your alternate angles. So angle 1 will be equivalent to angle 2 because AB is parallel to your CD. Right? We can say that easily. Now, because we know that BC is even parallel to your AD. That means BD will be the transversal for that. That means angle 3 will be equivalent to angle 4 because they are even alternate angles. Now what we are taking is in triangle. We are considering the triangle DAB. We are taking triangle DAB and your triangle, and along with that, which triangle will be taking? For this triangle DAB, this is angle 4 and this angle 4 is equivalent to your angle 3. So we will be considering triangle BCD. These two triangles we are considering, triangle DAB and your triangle BCD. These two triangles we are considering. In these two triangles, in this triangle angle 1 is equivalent to angle 2. Angle 1 of triangle DAB, in this triangle angle 1 is coming and in this triangle angle 2 is coming. So angle 1 is equivalent to angle 2 because they are your alternate angles. They are alternate angles, that's the reason they will be equal. Similarly, angle 4 of triangle ADB, that is angle 4, it is equivalent to angle 3 of triangle your BCD. Reason being they are the alternate angles. They are your alternate angles. Whenever there are two parallel lines and one of the transversal is intersecting these two parallel lines at two distinct points, then the angles which are formed as Z, these are your alternate angles. So these two angles will be equal. Now we can see in both the two triangles, your BD is common for both the two triangles. So BD is equivalent to your BD because it is common for both the two triangles. So we can see over here by ASA congruency, both the two triangles are congruent. So we can say that by ASA congruency rule, triangle DAB will be congruent to triangle BCD. These two triangles will be congruent. And we know that if two triangles are congruent by CPCT, that is corresponding parts of congruent triangles, their corresponding parts will even be equal. So what we can see is over here we have proved that these two triangles are congruent. Now what we need to prove is that they are automatically, because triangles are congruent, so we can conclude that by CPCT, their corresponding parts will even be equal. Now the corresponding parts we can see over here. Here DA corresponds to your BC. So DA will be equivalent to your BC because they are the corresponding parts. Similarly, your AB will be equivalent to your CD. They are even the corresponding parts. So AB will be equivalent to CD. So just now we have proved that the opposite sides are equal. We had taken that it was a parallelogram and just now we have proved that their opposite sides are equal. One of the thing is proved. Now we can see over here, now the corresponding angles will even be equal. So A corresponds to your C. Over here we can see A corresponds to your C. So angle A will be equivalent to your angle C. This is even your corresponding angle of the congruent triangles. That's the reason angle A will be equivalent to angle C. Now if angle A is equivalent to angle C over here, now we know that angle 1 is equivalent to angle 2. Angle 1 is equivalent to angle 2 and angle 3 is equivalent to angle 4. If I'll be adding, so angle 1 plus angle 3, we can write it as angle 1 could be written as your angle 2 also, and angle 3 could be written as angle 4 also, and angle 1 plus angle 3, it is your angle B. It is your angle B. Angle 1 plus angle 3 is your angle B, and angle 2 plus angle 4 is your angle D. So from here we can say that the opposite angles are equal. Here angle A is equivalent to angle C, that are the opposite angles, and angle B is equivalent to angle D, these are even the opposite angles. So this is how we can prove that the opposite angles of a parallelogram are equal. And just now we have proved that these two triangles are congruent. We had already proved that the diagonal is dividing the parallelogram into two triangles which are congruent or which are equal. Now similarly, if instead of this diagonal we would have taken AC as the diagonal, so in the same fashion we can prove it that these two triangles will even be or similar or your congruent. So this is how the only thing given to us was your that both the pair of opposite sides is parallel in the case of your parallelogram. But if this is the case, then we can automatically conclude that the opposite sides will even be equal, opposite angles will even be equal, and the diagonal will be dividing it into two congruent triangles. All these are the properties of a parallelogram. There are some more properties of a parallelogram that even we will be learning in this video. Just now we have seen some of the properties of a parallelogram, that in a parallelogram opposite sides are equal, opposite angles are equal, and the diagonal bisect the parallelogram. Now let's see some more properties of a parallelogram. The property is the diagonal of a parallelogram bisects each other. If we are going to take a parallelogram, suppose this is the parallelogram ABCD, ABCD, it is a parallelogram where AB is parallel to your CD and AD is parallel to your BC. Then if we'll be making both the diagonals of this parallelogram, that is your AC and BD, which are intersecting each other at the point O, then this O is bisecting both the two diagonals. That means what we need to prove is, we have to prove that OA is equivalent to OC and OB is equivalent to your OD. We have taken a parallelogram ABCD in which there are two diagonals AC and BD. What we need to prove was the diagonals of a parallelogram bisect each other. We have taken these two diagonals which are intersecting each other at the point O. Then this is the point O is the point which is bisecting both the two diagonals. That means OA will be equivalent to OC and OB will be equivalent to your OD. This we need to prove. How we can prove it? Given to us is that AB is parallel to your CD and AD is parallel to your BC. That means it is given to us that ABCD is a parallelogram, it is given to us, and AC and BD are the diagonals which are intersecting each other at point O. It is given to us. We have to prove that OA is equivalent to OC and OB is equivalent to OD. This we need to prove. So how we will be proving it? We will be considering two triangles. Which triangles will be considering? We will be taking triangle AOB, triangle AOB and triangle COD. These two triangles will be considering. We are considering this triangle AOB, this triangle, and your triangle COD, this triangle we are considering. We know that these two opposite sides, both the pair of opposite sides here are parallel to each other. That's the reason your angle, this angle is suppose angle 1. So over here we can see this is making Z. So angle 1 will be equivalent to angle 2 because they are your alternate angles. Similarly, we can see over here that AB is parallel to CD and BD is the transversal. So again, angle 3 will be equivalent to angle 4 because they are even your alternate angles. And just now we have proved that in a parallelogram, opposite sides are even equal. That means AB will be equivalent to your CD because it is a parallelogram, it is given to us. And just now we have proved that in a parallelogram, opposite sides are even equal. So we can take it as AB is equivalent to CD. So in these two triangles, in the triangle AOB, angle 1 is there. In the triangle COD, angle 2 is there. So angle 1 is equivalent to angle 2 because they are your alternate angles. Similarly, in the triangle AOB, there is angle 3. And in the triangle angle COD, there is angle 4. They are even equal because they are your alternate angles. Similarly, in the triangle AOB, AB is equivalent to CD of your triangle COD because they are opposite sides of a parallelogram, and opposite sides of a parallelogram are equal. So we can see over here by ASA congruency, these two triangles will be congruent. So by ASA congruency, we can say that triangle AOB will be congruent to triangle COD. These two triangles will be congruent, and we know if the triangles are congruent, then by CPCT their corresponding parts will even be equal. Now just now we have proved that the triangle AOB is equivalent to or the congruent to your triangle COD. So we can conclude by CPCT we can say that their corresponding parts will even be equal. So AO corresponds to your OC. So AO will be equivalent to your CO. We need to prove that AO is equivalent to OC, that we need to prove. So one of the thing we have proved it. Similarly, the corresponding part is your OB. For the triangle AOB, OB corresponds to your OD. So OB will be equivalent to your OD. That means your OA is equivalent to OC, this OA is equal to OC, and your OB, this OB is equivalent to your OD. This was to be proved that the point where these two diagonals are intersecting each other, this is the point which is bisecting both the two diagonals. So this is how we can prove the theorem, prove the statement. So what all the properties of a parallelogram we have learned till now, that opposite sides are equal, opposite angles are equal, diagonals bisect the parallelogram into two congruent triangles, and your diagonals of a parallelogram bisect each other. Till now we were saying that in a quadrilateral, if both the pair of opposite sides are parallel or equal, or the opposite angles are equal, or we can say the diagonals are bisecting each other, then we say the quadrilateral is a parallelogram. But there is one more condition by which, if that condition is fulfilled, so we can say that the given quadrilateral is a parallelogram. Let's see what the condition is. If in a given quadrilateral, if a pair of opposite sides of a given quadrilateral are equal and parallel, only one pair of opposite side is equal also and parallel also, then also we can say that the quadrilateral is a parallelogram. How we can say that? Just prove it. So we have taken a quadrilateral. Over here it is a quadrilateral. It is not given that it is a parallelogram. We need to prove it that it will be a parallelogram. So ABCD is any quadrilateral. It is a quadrilateral in which one pair of opposite sides are equal also and it is parallel also. So AB is parallel to your CD and AB is equal to CD also. This is what given to us is that one pair of opposite sides of a quadrilateral is equal also and parallel also. Now we have to prove that this is a quadrilateral. So what we will be doing is we will be making a diagonal. Like this, we have taken a diagonal. Now given to us is that there is a quadrilateral ABCD is given to us in which AB is parallel to your CD. AB is parallel to CD and AB is equivalent to CD. One pair of opposite sides is equal also and parallel also. What we have done is we have joined your AC. We have to prove that ABCD is a parallelogram. This we need to prove it. How we will be doing it? Let's see. proof is, in the triangle we'll be considering the two triangles. One will be your ABC. We will be taking triangle ABC triangle we have taken, and we will be taking CDA and triangle CDA. These two triangles we'll be considering. In these two triangles, it is given to us that AB is parallel to your CD. And if AB is parallel to CD, then this is your pose, this is your angle 1, and this is your angle 2. So angle 1 will be equivalent to angle 2 because they will be alternate angles, because AB is parallel to CD and AC is the transversal. So in the triangle ABC, angle 1 will be equivalent to angle 2 of triangle CDA. Reason being, they are your alternate angles. They are alternate angles. We can see over here that AB is equivalent to your CD because it is already given to us in the statement. Only it is given that one pair of opposite sides is parallel and equal also. So AB is equivalent to CD. So AB is equivalent to your CD. It is given to us. And we can see that AC is common for both the two triangles. In the triangle ABC also AC is coming. In the triangle CDA also your AC is coming. So AC is equivalent to AC because it is common for both the two triangles. So we can see that this side, this angle and this side, that means by SAS congruency, both the two triangles will be congruent. By your SAS congruency, we can say by SAS congruency, triangle ABC will be congruent to triangle CDA. These two triangles will be congruent by your SAS congruency. And we know that if two triangles are congruent, then their corresponding parts are even equal. So we can say that by CPCT we can conclude that if this is your angle, say 3, and this is your angle 4, suppose. So angle 3 will be equivalent to angle 4 because they are the corresponding angles. For the triangle ABC, we will be considering this angle 3. So it corresponds to angle 4 of the triangle your CDA. So angle 3 will be equivalent to angle 4 by CPCT we can conclude, because just now we have proved that the triangle ABC is congruent to triangle your CDA. And if these two triangles are congruent, then by CPCT we can conclude that their corresponding parts will even be equal. Corresponding sides will even be equal and corresponding angles will even be equal. So over here angle 3 corresponds to angle 4. So angle 3 will be equivalent to angle 4. Now, if we are going to see over here for the line segment, your BC and your AD, angle 3 and angle 4 are your alternate angles. These are your alternate angles, and we know that if alternate angles are equal, in that case your lines are parallel. So angle 3 and angle 4, angle 3 and angle 4 are your alternate angles. And we know that if alternate angles are equal, the lines are parallel. We know that if alternate angles are equal, so lines are parallel. That means BC will be parallel to your AD. Already your AB was parallel to CD, it was given to us, and just now we have proved that the opposite pair of your second pair of your opposite sides is even parallel. BC is even parallel to your AD. This just now we have proved. So if both the pair of opposite sides are parallel to each other, we say the quadrilateral to be a parallelogram. Now over here already given that one pair of opposite side was parallel. Just now we have proved that the another pair of opposite side is even parallel. Now because both the pair of opposite sides are parallel, therefore ABCD is a parallelogram. So this is how we can prove that if one pair of opposite sides are equal and parallel, then also the quadrilateral will be a parallelogram. So if any of the quadrilateral is given to us and we need to prove that the given quadrilateral is a parallelogram, so what all are the conditions by which we can prove that the given quadrilateral is a parallelogram? So first of the condition is both pair of opposite sides are parallel. If we prove that both the pair of opposite sides are parallel, we can say the given quadrilateral is a parallelogram. If both pair of opposite sides are equal, opposite sides are equal, then also we can say that the given quadrilateral is a parallelogram. If both pair of opposite angles, both pair of opposite angles are equal, then also we can say that the given quadrilateral is a parallelogram. If diagonals bisect each other, then also we can say that the given quadrilateral is a parallelogram. And if one pair of opposite side is equal and parallel, then also we can say that the given quadrilateral is a parallelogram. So if any of these conditions we can fulfill, we can prove, then we can say, we can conclude that the given quadrilateral is a parallelogram. Now let's understand some of the properties of a special type of parallelogram, that is rectangle. So what all the properties of a rectangle is, as we are saying that it is a parallelogram. So whatsoever the properties of a parallelogram is there, all the same properties will be followed by a rectangle also. But along with that, it is even having some more properties. Let's understand what all these properties are. Suppose we are saying that ABCD is a rectangle. This is A, B, C and D. ABCD is a rectangle. Now because it is a parallelogram also, so if it is a parallelogram, that simply means that opposite sides will be, both the pair of opposite sides will be parallel, both the pair of opposite sides will be equal, both the pair of opposite angles will be equal, diagonals will bisect each other. All these properties will be followed by a rectangle because it is a parallelogram. We just now discussed that parallelogram, there are some special type of parallelograms are even there. One is your rectangle, another is your rhombus, and then a square. All these will be learning in this video only. So right now we are discussing about rectangles. So because it is a parallelogram, so all the properties of a parallelogram will be followed by a rectangle. Along with these properties, what all properties a rectangle has is all its angles are 90 degree. All the angles of a rectangle is your 90 degree. That means angle A will be equivalent to angle B, will be equivalent to angle C, and will be equivalent to angle D. All will be your 90 degree. Along with that, both the diagonals are equal. Diagonals of a rectangle are equal. Rectangle are equal. That means if we'll be making the diagonals BD and your AC, then your AC will be equivalent to your BD. Both the diagonals will be equal. So this is about a rectangle, that in a rectangle, all the four angles will be on 90 degree. Both the diagonals will be equal. And what all the properties of a parallelogram was there, it is even following the properties. Now, if a quadrilateral is given to us and we have to prove that the given quadrilateral is a rectangle, then how we can prove it? If we can prove that all the angles of the given quadrilateral is 90 degree, then we can say that the given quadrilateral is a rectangle. See, if all the angles will be 90 degree, this A, B, C, D, all the four angles are 90 degree, then we can see over here 90 and 90, and some of interior angles on the same side of the transversal is 180 degree. That's the reason opposite sides will be a parallel, and we can conclude that it will be a parallelogram. So if any of the quadrilateral is given to us, if any quadrilateral is given and we need to prove that this quadrilateral is a rectangle, so what we need to prove is all angles are your 90 degree. If we can prove that all angles of the given quadrilaterals is 90 degree, then we can say that given quadrilateral is a rectangle. Now, if it is given that it is a parallelogram is given to us and we need to prove that the given parallelogram is a rectangle, how we can prove it? Now, because it is a parallelogram, so automatically it is given that opposite sides are equal, opposite sides are your parallel. All these things are automatically given to us. So what else we need to prove is, if we can prove that any angle out of these four, any angle is 90 degree. Any of the angle is 90 degree if we can prove out of these four angles, if any of the angle is 90 degree, if we can prove this, then we can say that the given parallelogram is a rectangle. Along with that, if we can prove the diagonals are equal, diagonals are equal, if we can prove this in the given parallelogram, then also we can conclude that the given parallelogram is a rectangle. So what all the properties of a rectangle is? Opposite sides are equal, so AB will be equivalent to your CD and AD will be equivalent to your BC. It is a property of a parallelogram, so it will even follow it. Opposite sides will be parallel even, so AB will be parallel to your CD and AD will be parallel to your BC. Opposite angles will be equal, so angle A will be equivalent to angle C and angle B will be equivalent to angle D. Diagonals will bisect each other, so if this is the point O, then OA will be equivalent to OC and your OB will be equivalent to OD. And along with that, all the four angles are your 90 degree and both the diagonals are equal. All these are the properties of a rectangle. So if it is given that it is a given quadrilateral, we need to prove that the given quadrilateral is a rectangle. Simply we need to prove is that all the angles, all the four angles are your 90 degree. If we can prove this, we can conclude that the given quadrilateral is a rectangle. If it is given that parallelogram is given to us and we need to prove that the given parallelogram is a rectangle, then if either of these two things we can prove it, like if any of the angle out of these four angles, if we can prove that any of these four angles is 90 degree, then we can conclude it will be a rectangle. Or if we can prove that both the diagonals are equal in the parallelogram, then also we can say that the given parallelogram is a rectangle. Now, one of the property of a rectangle is, just now we said the diagonals are equal and bisect each other. It is one of the property, bisect each other. So how we can prove it? The diagonals of a rectangle are equal and bisect each other. If we have to prove, how we can prove it? So let's see. This is your A, this is your B, this is your C, this is your D. Now we have taken this diagonal and this your diagonal. These are the diagonals which we have taken. What we need to prove is that the diagonals are equal. So what we will be doing is, given to us is that ABCD is a rectangle. It is given to us, right? And what we need to prove is diagonals are equal. That means AC is equivalent to BD. This we need to prove first of all. And if this is an intersection point, along with that, what we need to prove is OA is equivalent to OC and OB is equivalent to OD. This we need to prove. What we need to prove is that diagonals AC is equivalent to diagonal BD. This we need to prove. Along with that, we need to prove that the diagonals are bisecting each other even. That means OA will be equivalent to OC and OB will be equivalent to OD. Now, first of all, we are doing the proof of it. So we will be considering triangle ADC. This triangle we are taking ADC and ADC we have taken. Along with that, which triangle will be taking? BCD. Triangle will be taking BCD. We have taken triangle ADC. This triangle we have taken, and another triangle is your BCD we have taken. In these two triangle, now see over here in the triangle ADC, your AD will be equivalent to BC of triangle your BCD because they are opposite sides of rectangle. Opposite sides of rectangle, and rectangle is a parallelogram, and in the parallelogram opposite sides are equal. Opposite sides of rectangle, that's the reason they will be equal. Now CD is equivalent to CD because in the triangle ADC also CD is coming. In the triangle your BCD also your CD is coming. So CD is common for both the two triangles. For this triangle even your CD is there, and for this triangle even your CD is there. So CD is common for both the two triangles. So we can take CD is equivalent to CD. This side we have taken. Now what is ADC? This angle ADC, that means angle D, is equivalent to your angle BCD. That is your this angle, because both of them are your 90 degree. Just now we said that in a rectangle all the four angles are your 90 degree. So angle ADC will be equivalent to angle BCD. Both are your 90 degree. It is given to us that all the angles of a rectangle are your 90 degree. Now what we can conclude over here is, see, by this is your SAS. By SAS congruency rule, both the two triangles will be congruent. So by SAS congruency, triangle ADC will be congruent to triangle BCD. These two triangles will be congruent, and if these two triangles are congruent, their corresponding parts will be equal. So the corresponding part AC, and over here corresponds to AC is your BD. So by CPCT, we can say that your AC will be equivalent to your BD. This AC will be equivalent to BD. So we can say that in a rectangle, your diagonals are equal. One of the thing we have proved that in the rectangle, your diagonals are equal. Now we have to prove the diagonals are bisecting each other even. Now if we need to prove it, so what we can take is, we can take one of the triangle as your AOB and another triangle as your COD. So we are considering in triangle AOB and triangle COD. These two triangles we are considering, AOB and COD. These two triangles we are considering. In these two triangles, AB will be equivalent to your CD. AB will be equivalent to CD. They are opposite sides of your rectangle. Opposite sides of rectangle. That's the reason this will be, AB will be equivalent to your CD. We know that opposite sides AB and CD are parallel even. So if this is your angle 1 and this is your angle 2, so angle 1 will be equivalent to angle 2. They are your alternative angles. So angle 1 is equivalent to angle 2. They are your alternate angles. Similarly, because these two lines are parallel, so angle 3, if this is your angle 3 and this is your angle 4, so angle 3 will be equivalent to angle 4. Again, they are your alternate angles. Angle 3 will equivalent to your angle 4. They are your alternate angles. So what we can conclude over here is that by ASA congruency, these two triangles are congruent. We can say that by ASA congruency, triangle AOB will be congruent to triangle COD. And we know that if the triangles are congruent, then their corresponding parts are even equal. So we can say corresponding part of AO will be your OC. So AO by CPCT we can say, CPCT full form is corresponding parts of congruent triangles. So AO will be equivalent to your CO. AO will be equivalent to your CO. These two parts are equal. And your OB corresponds to your OD. So your OB will be equivalent to your OD. That means your OB will be equivalent to your OD. So this is how we can prove that in a rectangle, diagonals are equal also and diagonals bisect also. So all these are the properties of a rectangle. Rectangle is a special type of parallelogram. So what all the properties of a parallelogram will be there, the same will be followed by your rectangle also. But along with this, it is even following some more properties. One of the properties is that all the angles of a rectangle is 90 degree. And another property is that both the diagonals are equal in the case of a rectangle. Now let's understand about one more type of parallelogram, that is your rhombus. So rhombus is even a type of parallelogram only. That means what all the properties of a parallelogram is there, all the properties will be followed by a rhombus also. Some other properties along with these properties are even followed by a rhombus. Let's discuss about all these properties. So what rhombus is? Suppose we have made this as your rhombus. It is even a parallelogram, as just now we said that ABCD is even a special type of your parallelogram only, that is known as your rhombus. So for the rhombus, all the four sides are equal. All four sides of a rhombus are equal. That means AB will be equivalent to BC, will be equivalent to CD, will be equivalent to your AD. All the four sides of a rhombus will be equal. Along with that, it is even following one more property, that diagonals of a rhombus, diagonals are perpendicular bisector of each other. That means if we will be making two diagonals in the rhombus, then they will be bisecting each other at 90 degree. If this is the point of intersection O, then all these angles will be your 90 degree. These are the two special properties of a rhombus. Along with all the properties of a parallelogram, rhombus is following these two properties also. That means what all the properties of a rhombus is, opposite side, both the pair of opposite sides are your equal also and your parallel also. Opposite angles are equal. Diagonals bisect each other but at 90 degree. It is bisecting each other at 90 degree. Diagonals are perpendicular bisector of each other, and all the four sides of a rhombus is your equal. All these are the properties which are being followed by your rhombus. So if it is given to us that it is a quadrilateral, any of the quadrilateral is given to us and we need to prove that the given quadrilateral is a rhombus, then what we need to prove is that all the four sides are equal. All the four sides are equal, that we need to prove, and diagonals are perpendicular. Diagonals are perpendicular bisector. If we will be proving these two things, then we can say that the given quadrilateral is a rhombus. And if it is given to us that it is a parallelogram, any parallelogram is given to us and we need to prove that the given parallelogram is a rhombus, then what we need to prove is, we need to prove that the any pair of adjacent sides are equal. That means if we will be proving that CD is equivalent to CB, then it is sufficient to prove that the given parallelogram is your rhombus. Along with that, what we can prove is the diagonals are your bisecting at 90 degrees. Already they are bisecting because it is the case of a parallelogram, that in every parallelogram diagonals bisect each other. But if they are bisecting at 90 degree, then we will say that the given parallelogram is a rhombus. Diagonals are perpendicular bisector. If they are perpendicular bisector, then we will say that the given parallelogram is a rhombus. So if quadrilateral is given, then we need to prove that all the four sides are equal and diagonals are perpendicular bisector. If we will be proving both the things, then we can say that the given quadrilateral is a rhombus. And if it is given that it is a parallelogram and we need to prove that the given parallelogram is a rhombus, then we have to prove is any pair of adjacent sides are equal. If we can prove that this side is equal to this side or this side is equal to this side, then we will conclude that it will be a rhombus. Why so? Because already we know that the opposite sides are equal. So if any one pair of adjacent side is equal, then we can automatically conclude that all the four sides are equal. Along with that, if diagonals are perpendicular bisector, then we can say that the given parallelogram is a rhombus. Now, the property of a rhombus, just now we are saying that diagonals of a rhombus are perpendicular bisector of each other. It is an important theorem related to your rhombus. So how we can prove this theorem? So we have taken a rhombus like this. This is a rhombus A, B, C, D. What we need to prove is that diagonals are bisecting at your 90 degree. They are bisecting at 90 degree. So if they are bisecting at your O point, the diagonals are your AC and BD are the diagonals which are bisecting at your O point, then we need to prove that the diagonals are equal, means OA is equivalent to OC and OB is equivalent to OD. That means they are bisecting and these angles, this angle, all these angles are your 90 degree. So how we can prove it? So given to us is that ABCD is a rhombus. ABCD is a rhombus, it is given to us. We need to prove, suppose this is your angle 1, this is your angle 2, this is your angle 3, this is your angle 4. We need to prove is angle 1 is equivalent to angle 2 is equivalent to angle 3 is equivalent to angle 4 is equivalent to 90. This we need to prove it. And along with that, diagonals are bisecting even. So we need to prove that this is O point. So OA is equivalent to OC and OB is equivalent to OD. This we need to prove. So how we can do that? First of all, we are considering the triangle, your AOB, triangle AOB, and another triangle we are considering is your COD, triangle COD. These two triangles we are considering, triangle AOB and triangle COD, these two triangles. Now in these two triangles, AB is equivalent to CD, because in rhombus all the four sides are equal and these are the opposite sides of a parallelogram. That's the reason even they will be equal. So AB is equivalent to CD because they are opposite sides, or we can say sides of a rhombus, because see, all the four sides of a rhombus are equal, so it doesn't make a difference whether it is opposite side or adjacent sides. For a rhombus all the four sides are equal. So because these are the sides of a rhombus, that's the reason AB will be equivalent to your CD. So we need not to write opposite, simply sides of a rhombus even will go. Now in these two triangles we are considering, again opposite sides are parallel, we know, because it is a parallelogram also, because all the properties of a parallelogram will even be followed by rhombus. So this is your angle, say 5, and this is your angle 6. So angle 5 will be equivalent to angle 6, reason being they are alternate angles. Similarly, if this is angle 7 and this is your angle 8, so angle 7 will be equivalent to angle 8 because they are even your alternate angles. Now angle, side angle of this triangle are equivalent to angle, side angle of this triangle. So we can say that by ASA congruency, triangle AOB will be congruent to triangle COD. These two triangles will be congruent, and we know that if the triangles are congruent, then by CPCT their corresponding parts will even be equal. So AO will be equivalent to your OC. So by CPCT we can conclude that AO will be equivalent to your OC and OB will be equivalent to your OD. The corresponding parts will be equal. So one of the thing we have proved that OA is equivalent to OC and OB is equivalent to OD. This we have proved. Now what we need to prove is that these angles, the diagonals are bisecting at 90 degree. These angles are your 90 degree. This we need to prove. So how we can prove it? Now we'll be considering triangle. Let's see DOC. We are taking the triangle DOC. This triangle we are taking triangle DOC, and this triangle and your triangle BOC. Triangle BOC. These two triangles we are considering. Now in these two triangles, just now we said that OB is equivalent to OD. This OB, in this triangle OB is coming and this is OD is coming. So OB of this triangle is equivalent to OD of this triangle. So OD is equivalent to your OB. Just now we have proved that diagonals are bisecting. So OB will be equivalent to OD. So we have taken because just now proved. Or we can say if this is your equation number 1. So we can say by equation number 1. We can say that OB is equivalent to OD. Now in these two triangles, your OC is common for both the two triangles. OC is common for both the two triangles. And BC of this triangle is equivalent to CD of this triangle because they are sides of a rhombus. So here we can see CD of this triangle is equivalent to BC of this triangle because they are sides of a rhombus. So we can say that by SSS congruency, because all the three sides of this triangle are equivalent to the corresponding three sides of this triangle. So by SSS congruency, triangle DOC will be congruent to triangle BOC. These two will be congruent to each other. Now, if the triangles are congruent, we know that by CPCT, their corresponding parts will be equal. Now, we can see for this triangle angle 1 and for this triangle angle 2, they are the corresponding parts, corresponding angles. So we can say angle 1 will be equivalent to angle 2. Their corresponding angles will be equal. By CPCT, we can conclude it. Because triangles are congruent, just now we have proved. So we can say that by CPCT, your corresponding angles will be equal. So angle 1 will be equivalent to angle 2. Now we can see over here that BD is a straight line. That means this angle 1 and angle 2, they are your linear pair of angles. Angle 1 and angle 2 is a linear pair of angle. So angle 1 plus angle 2 will be your, sum of these two will be 180 degree because they are linear pair of angles. And we know that for the linear pair of angles, sum is your 180 degree. So angle 1 plus angle 2 is 180 degree. From here, angle 1 could be written as angle 2 or angle 2 could be written as angle 1 also. So instead of angle 2, I am writing angle 1. So it will be angle 1 plus angle 1 is 180 degree. Or I can say 2 times of angle 1 is 180 degree, or angle 1 is 180 divided by 2, that is your 90 degree. And just now angle 1 is equivalent to angle 2. So angle 2 is equivalent to angle 1 is equivalent to 90 degree. So this is how we can prove that all the four angles of the point where the diagonals are bisecting each other, they are your 90 degree, or we can say that the diagonals of a rhombus are perpendicular bisector of each other. So this is how we can prove the theorem. This is how we can prove the statement. So what all the properties of a parallelogram is there will be followed by rhombus also. The special properties which are belongs to your rhombus is your all the four sides of a rhombus are equal and diagonals are your perpendicular bisector of each other. Now let's understand the properties of a square. A square is even a special type of parallelogram only. That means what all the properties of a parallelogram is there will be followed by square also. But along with that, it is even having some more properties. Let's discuss about all these properties. So square, suppose we are having this ABCD as your square. ABCD is a square. Then what all the properties of a square is that all the four sides are equal. All sides are equal in the case of a square. All the angles are 90 degree. All angles are 90 degree. Diagonals are equal. These are the diagonals. So diagonals are equal. Diagonals are equal. Along with that, diagonals are perpendicular bisector of each other. Both the diagonals bisect each other at 90 degree. That means these angles are your 90 degree. So along with all the properties of a parallelogram, what all properties a square has, that its all the four sides are of equal measurement, all the angles are 90 degree, diagonals are equal, and diagonals are perpendicular bisector of each other. All these are the special properties of a square. So we can see that all the properties of a parallelogram is being followed by a square. All the properties of rectangles are also followed by your square, and all the properties of rhombus is even followed by your square. So square is a parallelogram also, it is a rectangle also, it is a rhombus also. But although all the rhombus will not be a square, all the rectangle will not be a square, all the parallelograms will not be square, but all the squares will be parallelogram also, your rectangle also, your rhombus also, and it is a quadrilateral obviously because it is having your four sides. So if any of the quadrilateral is given to us, how we can prove that the given quadrilateral is a square? For that we need to prove that all the sides are equal, all the angles are 90 degree, your diagonals are equal and diagonals bisect each other at 90 degree. If we will be proving all these things, then we can say that the given quadrilateral is a square. Now, if any of the parallelogram is given to us and we need to prove that the given parallelogram is a square, then what we need to prove is that the adjacent sides are equal, because in the parallelogram already opposite sides are already equal. So if we will be proving that the adjacent sides, any pair of adjacent side is equal, if we can prove that, then we will be saying that the given parallelogram is a square. Along with that, all the angles should even be on 90 degree. All these four angles should even be on 90 degree. If all the four sides are equal and all the angles are 90 degree in a parallelogram, along with that diagonals are equal and diagonals intersect at 90 degree. If we can prove this, we will be saying that the given parallelogram is a square. For that, we need to prove that the adjacent sides are equal, because if adjacent sides will be equal, we can directly say that all the four sides are equal. If any one of the angle will be 90 degree, then we can say that all the four angles will be 90 degree, because in a parallelogram already opposite angles are your equal only. So if your any of the angle is 90 degree, we can prove any adjacent sides are equal, or your diagonals are equal and diagonals are your intersecting at 90 degree. If we can prove that, then we can say that the given parallelogram is a square. Now, if it is given to you that it is a rectangle, any of the rectangle is given to us and we need to prove that the given rectangle is a square, then what we need to prove is, we need to prove that the adjacent sides are equal. Because see, again in the rectangle opposite sides are equal. So if we will be proving that the adjacent sides are equal, then it means your all the four sides will be equal. Along with that, if diagonals intersect at 90 degree, if the diagonals will be intersecting at 90 degree, then we can say that your given rectangle is your square. Because already in the case of rectangle, we have seen that all the angles are 90 degree. So we need not to prove it, because it is given that it is a rectangle. That means all the angles are 90 degree. If it is a rectangle, that means diagonals will be equal. So we need not to prove that, because it is already a rectangle given to us. We have to prove that the given rectangle is a square. For that, we need to prove that the adjacent sides are equal, so that all the four sides will become equal and diagonals intersect at 90 degree. If we will be proving these, we can say that the given rectangle is a square. Now, if a rhombus is given to us and it is said to prove whether the given rhombus is a square or not. So what we need to prove is that all the angles should be 90 degree. That means it will be proving all the angles to be 90 degree and diagonals equal. Then we can say that the given rhombus is a square, because already in the rhombus all the four sides are equal. And in the rhombus, diagonals bisect each other at 90 degree. So we need not to prove these. And only we need to prove for a rhombus to be a square is that all the angles should be on 90 degree, all these angles should be 90 degree, and your diagonals should be equal, because in the case of rhombus, diagonals are not equal. So hope it is clear how we can prove a quadrilateral to be a square, a parallelogram to be a square, a rectangle or a rhombus to be a square. Now, the properties of a square we have seen that all the four sides are equal, all angles are 90 degree, diagonals are equal, diagonals are perpendicular bisector. Along with that, all the properties of parallelogram, even that your both the pair of opposite sides are your parallel even, already they are equal and angles are 90 degree, so angles are even equal. So all these are the properties which are being followed by your square. So square is following all the properties of a quadrilateral, parallelogram, rectangle, rhombus. All these properties are being followed by your square. So we can say that square is your quadrilateral also, parallelogram also, rectangle also, and rhombus also. Although it is not compulsory that a rhombus will be a square, rectangle will be a square, the parallelograms will be the square, or the quadrilateral will be the square. It is not compulsory, it can be. Now let's see the important property of a square just now we discussed is that diagonals of a square are equal and perpendicular bisector of each other. this we need to prove that in a square diagonals are equal also, and they are bisecting also, and at 90 degree also they are bisecting each other. So we have taken this a square. This is your A, B, C, D. It is a square. All the four sides will be equal. All the angles will be 90 degree. We need to prove that the diagonals are equal. First of all, we will be proving that the diagonals are equal. This is the O point we have taken where the diagonals are intersecting each other. So first we are considering in triangle ADC. This triangle we are taking ADC and triangle BCD. BCD. ADC, this triangle we are taking, and triangle BCD, this triangle we are taking. In these two triangles, AD is equivalent to your BC because they are sides of a square, and all the four sides of a square are equal, so they will be equal. In the triangle ADC, your DC is coming. In the triangle BCD also your DC is coming. So your DC is equivalent to DC. It is common for both the two triangles. Now in the triangle ADC, your angle D is 90 degree. In the triangle BCD, your angle C is 90 degree. So angle ADC is equivalent to angle BCD. Both are your 90 degree. So we can say that by SAS congruency, both the two triangles will be congruent. So we can say that by SAS congruency, triangle ADC will be congruent to triangle BCD. And if these two triangles are congruent, then by CPCT, their corresponding parts will be equal. So by CPCT, we can say that AC corresponds to your BD. AC will be equivalent to your BD. AC will be equivalent to BD. So first thing we have proved that the diagonals are equal. First thing is done. Now we are proving that diagonals are bisecting each other. So second we will be considering triangle. We need to prove that they are bisecting each other. So we are considering triangle AOB, triangle AOB and triangle COD. These two triangles we are considering, and triangle AOB and triangle COD. These two triangles we are considering. In these two triangles, AB is equivalent to your CD. They are sides of a square. All the four sides of a square are equal. So these are sides of a square. If this is your angle 1 and this is your angle 2. So angle 1 will be equivalent to angle 2. They are alternate angles because AB is parallel to CD and AC is the transversal. So angle 1 will be equivalent to angle 2. They will be the alternate angles. Similarly, if this is angle 3 and this is angle 4. So angle 3 will be equivalent to angle 4. They are again your alternate angles. So we can say that by ASA congruency, triangle AOB will be congruent to triangle COD. These two triangles will be congruent. And if triangles are congruent, we can say that by CPCT, their corresponding parts will be equal. So AO will be equal to your OC corresponding parts, and OB will be equivalent to your OD. The corresponding parts will be equal. That means OA equivalent to OC and OB equivalent to OD. That means diagonals are bisecting each other. Now the third thing which we need to prove is that diagonals are bisecting at 90 degree. That means these angles are 90 degree. If this is your angle 4, already 4 is there. So this is 5 and this is your 6. Then we need to prove that all these angles will be on. If these are 90 degree, we can easily prove that rest all will even be 90 degree. Now we'll be considering triangle DOC. Triangle DOC and triangle BOC. Triangle BOC. These two triangles we are considering. In these two triangles, your DC will be equivalent to your BC. They are the sides of a square. So DC will be equivalent to your BC. They are sides of a square. That's the reason they will be equal. Now, OC is common for both the two triangles. OC is here also in this triangle and in this triangle. So, OC is equivalent to OC. It is common for both the two triangles. Along with that, just now we have proved that OB is equivalent to OD. Just now we have proved that OB is equivalent to OD. So, OB is equivalent to, in this triangle OD is there and in this triangle OB is there. Just now, if this is our equation number 1, so from equation number 1 we can say that OB is equivalent to OD. So we can say that by SSS congruency, all the three sides of this triangle is equivalent to all the three corresponding sides of another triangle. So by SSS congruency, triangle DOC will be congruent to triangle BOC. And if these two triangles are congruent, we know that by CPCT, their corresponding parts will even be equal. That means corresponding part for this triangle 5 angle and for this triangle it is your angle 6. They are the corresponding parts. So angle 5 will be equivalent to angle 6. But if we are going to see angle 5 and angle 6, they are on the straight line. That means they are linear pair of angles. So angle 5 plus angle 6 is your 180 degree. If this is your angle equation number 2, because they are linear pair of angles. Linear pair of angles. Now instead of angle 5, I can write angle 6 also, and instead of angle 6, I can write angle 5 also. So angle 5 plus angle 5 is equal to 180 degree, or 2 times of angle 5 is 180 degree, or angle 5 is your 180 divided by 2, that is your 90 degree. And because angle 5 is equivalent to angle 6, so angle 5 equivalent to angle 6 is equivalent to 90 degree. That means diagonals are bisecting each other at 90 degree. So this is how we can prove that the diagonals of a square are equal. Diagonals of a square are bisecting each other, and diagonals of a square are perpendicular bisector of each other. That means bisecting at your 90 degree. So this is all about your square. What all the properties of a square just now we discussed. All the sides are equal. All the angles are 90 degree. Diagonals are equal. Diagonals are your perpendicular bisector of each other. Along with that, all the properties of a parallelogram will even be followed by your square. So just now we have discussed all the special cases of your parallelogram, that is your rectangle, your rhombus, your square. All these are your comes under the category of your parallelogram only. All the three are your parallelograms. Now let's discuss about one more type of quadrilateral, that is your kite. What kite is and what all the properties of a kite is, that we'll be discussing just now. Over here we have taken a kite. A, B, C, D is a kite, and in this kite, or in all the types of kites, your adjacent sides, both the pair of adjacent sides are equal. So AB will be equivalent to your AD and your BC will be equivalent to your CD. BA will not be equivalent to your BC. Only these two sides, and these two sides will be equal in a kite. So AB will be equivalent to AD and your BC will be equivalent to your CD in the kite. Along with that, your diagonal AC will be perpendicular to the diagonal BD. Both the two diagonals, your diagonal AC will be perpendicular on the diagonal your BD. That means your all these angles, this angle, all these angles will be on 90 degree because they are perpendicular to each other at the point O. That's the reason all these four angles will be on 90 degree. So your adjacent sides are equal, diagonals are perpendicular to each other. Along with that, your angle ABC, this angle will be equivalent to angle ADC. These two angles will be equal. Angle ABC, this angle will be equivalent to angle ADC. These two angles will be equal. Just now we said because diagonals are perpendicular to each other, so all these four angles, that is angle AOB, this angle is equivalent to AOD, is equivalent to DOC, is equivalent to BOC. All these four angles will be on 90 degree. The bigger diagonal AC will be bisecting your smaller diagonal BD. That means O will be the midpoint for your BD. For the diagonal BD, O will be the midpoint. Although O will not be the midpoint for your diagonal AC. only your bigger diagonal is bisecting your smaller diagonal. Bigger diagonal is not being bisected. So your OB will be equivalent to your OD. Along with that, your angle, this angle, angle 1 will be equivalent to angle 2. That means your bigger diagonal is bisecting your angles also. At the vertex A also and at the vertex C also, this diagonal AC is bisecting your angle A also and angle C also. That means angle 1 will be equivalent to angle 2 and angle 3 will be equivalent to angle 4. All these are the properties of a kite. So what we discussed is, in the kite, that both the pair of adjacent sides are equal. Your AB will be equal to AD. Your BC will be equivalent to your CD. These two sides and these two sides will be equal. Diagonals will be perpendicular to each other. That means these angles, these four angles will be your 90 degree. This angle will be 90, this will be 90, this will be 90, this will be 90. All these four angles will be your 90 degree. The bigger diagonal will be bisecting the smaller diagonal. That means OB will be equivalent to your OD. These two sides will be equal. Bigger diagonal will be bisecting your smaller diagonal, and the bigger diagonal will be bisecting your angles also. So angle vertex A and vertex C, at these two vertex, when we will be joining this, that will be your diagonal AC, and this diagonal AC will be bisecting angle A also and angle C also. That means angle 1 will be equivalent to angle 2. Over here we can say angle 1 will be equivalent to angle 2 and angle 3 will be equivalent to angle 4. This diagonal will be bisecting the angles. So what we all have discussed, all these are the properties of your kite. Along with that, your these angles, angle B, this is your angle A, B, C. This angle will be equivalent to angle A, D, C, this angle. These two angles are even equal. So all these are the properties which are being followed by a kite. So what we discussed in this video is that quadrilaterals are the parallelogram, your polygons. Quadrilaterals are the polygons with your four sides. Polygons with the four sides are known as your quadrilaterals. Quadrilaterals are of three types. One is your trapezium. We had already discussed about it, all the properties of a trapezium and an isosceles trapezium even. Then your parallelogram and then your kite. These three are the types of your quadrilaterals. Quadrilaterals are four-sided polygons, right? That means figures which are only made up of line segments and are closed even, that is your quadrilaterals are. So all these will be the quadrilaterals. Trapezium, parallelogram and kite are the three types of your quadrilaterals. Under the category of parallelograms, again we are having rectangle is a type of parallelogram. We are having rhombus, again a type of a parallelogram, and your square. So this is all what we have discussed in this video. All the properties of all these figures we have discussed. Hope it is clear to you that what all these figures are, what all the properties they are having, and how we can prove it, all the theorems even. Soon we'll be coming with the more videos on other chapters of class 8 maths curriculum. Thank you.